So for problem 3, you have that after the softball leaves your hand, it rises, slowing down. So basically, we just have a ball going in the upward direction. So I'll let that be my little sketch. And then first we have to specify the system then. So the only object in this problem is the ball. So for our system, it will just be the ball. So I'm going to go ahead and draw the motion diagram of the ball rising into the air. So first, right when the ball leaves the hand, its position would be right here. Then after 1 second, its position will be right here. After another second, its position will be here. After another second, position will be here. After one more second, position's here. And let's let the final position be right here then. Notice that after each second, the distance between its position gets smaller and smaller and smaller. But that represents that the ball is decreasing its velocity as it's rising. So this is my motion diagram for this. I could represent the ball's velocity with vectors. So at this point, I could draw my vector as this. Here's my velocity vector. Now, since at each ball's location its velocity is decreasing, the velocity vector should be getting smaller, 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 and then finally at the very top there is no velocity vector because when it's at its maximum height, the ball's velocity is 0. Next, I'm going to draw a free body diagram. So I'm going to represent the ball as a dot. And because it's not touching any surface, there is no normal force, unlike in problem 2. So the only force that acts upon the ball is gravity. So I'm going to go ahead and draw a vector, go pointing downward, and I will represent that with the F. And this is my free body diagram. And now let's indicate the direction of the acceleration and of the net force then. So for the acceleration, since the only force that's acting upon the ball is gravity and that pulls the ball downward, the direction for the acceleration has to also be downward then. So I'm going to just put acceleration downward. And the net force then. So there's only one force, that's the force of gravity, and the force of gravity acts in the downward direction. So for the net force, it's also going to be downward then.